Okay, today I'm going to make a video on Algebra 2. This is Illustrative Mathematics, Unit 4 and lesson number 15. And the topic of the lesson is there are two parts, part 1 and 2. This is 15 is using graphs and logarithms to solve problems. So they're going to use one thing is using the graphs, and the second thing is also using the logarithm. How does undo function, which is the inverse function logarithm of the exponential, helps us to find out to solve the equation. So let's go the first. The goal of the lesson here is learning target is I can solve equations using logs by graphing. Okay, so let me go straight away to the students talk. This is what I'm gonna walk through some of those whatever possible. So the first one is here it is using 15.1 using the graph to estimate. So you see the graph, and the graph is exponential function. So here is a graph of exponential function, but the base used is the e, and that's it. So this is that f of x is e raised to x. And the first question is asked, explain how to use the graph to estimate estimate logarithms such as. So what is this ln of 100 from this table? Sorry, so from this graph, can we identify what is this ln of 100? Now, we understand. So what I'm going to do is make a table out of this. I already have this. This is the same graph. So I'm going to make a table to have a intuitive understanding of what's going on. So this is the input, and this is the exponential function, that is f of x equals e raised to x. And then you can see these are, because they give us 0, 1, so this is 0, 1, 2, 3, and 4. And there's also 5. And what you see is the point 1, 2, 3, 3. So these are the points we need to, sorry, this one and here. So what does it mean is you plug in each time. So if I want to know what goes right here, it's basically e raised to 0. We don't need a calculator to figure out this because we know e raised to 0 is, so e raised to 0 is 1. And so I'll just write answer is 1. We can also check with the calculator. And the reason is we've seen in the laws of logarithm, properties of exponential function. So we have seen that e raised to 0 is 1. So next is, what about this one? So now so first I plug in x is 0, then I plug in x is 1, so it is going to be e of 1. This will be e raised to this, when I plug this is going to e square, and so on. So these are e raised to 4 and e raised to 5, just to get an understanding. And then we can figure out this with the help of what are the actual answers. And therefore that I'm going to use the calculator TI-84 first. So here I open the TI-84 plus C calculator. So put it on. So it's already on. Now click on second mode to get the screen in case you have some other stuff going on the screen. Or maybe you have an error, you just click second mode. And then we need to know what is e raised. So the thing is, let's check. We need to know e raised to 0, e raised to 1 is squared. And then we'll plug this in the. So e raised to the, even though we know the answer, but still, I'll click here. So click on second ln. Oh, sorry, I made a mistake. So let me go back to this and click on second ln. And there it shows, put a 1. And then enter, you get, sorry, the first one I should be putting is e. I did this one is e raised to 1, and that is 2.7. So 2.718. I'll just write, then e raised to 0 again, second e, and put a 0 and enter, you get 1. So that is 1. Then we'll put, let's plug in second, put 2, you get 7 point something. So that's 7.389. And then So likewise, if to get used to the calculator for 3 and enter, you get 20 points. So that's 20.085. And then let's put plus 2 e raised to 4, enter, you get 54, which is 54.9, which is 54.6. And then the last one is second ln, and you put 5, enter, you get 148. 148.4. Now I'm gonna go back to this and plug it in. So what did we get here is, because the first one is 1, we got this is 2.7, this is 7 point, rounding to the one place decimal, this will be 20.1, then 54.6, and the next one is 148. So all this, what this means is for each input, so this piece, that is, this is that which is 0 and 1. This is 1 and 2.7. The reason I'm showing is input output, because we are going to use logarithm, the inverse function. So this is uh, 2.7 here. So this piece is 2 is 7.4, and the next one is this is 3 is 20.1, then 4 is 54.6, and this piece is 5 is 148. So that's what this means. So now, what does what E does is, what is the role of E? Is you give any input to E, so you get this output. But we want to get how does the relation L, how does ln, what does this means to you? So the question is asking like what? So they're asking you, the question is, let me pull out the question here. The question is, explain how to use to estimate logarithms such as. So how do you do, what is the ln of 100? So let's see what is the meaning of this. So when you say ln of 100, basically means it is a logarithm with the base e and of 100. And then let's imagine we don't know the answer. Let's put it like some variable p by definition of. So this goes for the question number 1. You see question number 1, by definition of logarithm, because log is the e is because of the exponential. So the base used here is e. So that's the e, the red color. So it is e raised to the p, the blue color, p equals the black 100. So this is 100 here. See, so that's 100. So and then when you once you notice, then you think, oh wow, we have the same thing. To this part, it is like e raised to x equals 100. It is like getting how to, where is this? So for the function e raised to x that you see here, e raised to x here. So e raised to x, we want to know when is this going to be 100. So I can try to write one x output here to see. So somewhere here in between here, between 4 and 5, see, because this is 54, this is 148. So in between there is that 100. So for, sorry, the output is, so let me take, okay. So here the output is 100. So this is output is 100. That's the output. So we want to know for what output, for what input. So what is this x? So what is this x equal, so that, so the f of that x is 100. So that's the question. So how do we find? So what this basically means, I wrote it as p. Okay, so this is the p. So there it is p. So what should be p? So this is that p. What should be this p? So that e raised to p is 100, which is the output 100. And from the calculator, it means at 100 is. So the question was, uh, explain how to use the graph to estimate logarithms such as. So what is this? How do we use a logarithm to figure out? So we need to know this basically means this p, and then we realize you get this piece. It means what e raised to what number? So the basically this means e raised to what exponent gives you 100. So to figure out that part, we can use the graph. Look at this graph. So that the graph is right here. In this graph, so I'll take off this, and we can easily calculate or estimate, not exactly the value. So we can estimate from here. So the output has to be 100. This is the 100. This is that. This is the. This is that p. Sorry, not the p. This is that e raised to p that we want to know is 100. So that's like 100. So you go all the way. This is so draw a horizontal line like this way that intersects. So draw a horizontal line that intersects this piece here. So we already get this piece. So this is e raised to x, and we want to know when is this going to be 100 output. And then from here you go all the way go down, and approximately we can write that's going to be p, and the p is between 4 and 5, almost like 4.6 here. So that's the answer for. So the question was, what is this PC? So this is estimate is 4.6. Now we want to check whether it is really gives you 4.6. So on the calculator, let's do. So on the calculator, so the third question is asking you, how can you use a calculator to check your estimate? What would you enter into the calculator? So the third question is, let's put it, so e raised to 4.6. And if you use the calculator, again, I already showed how to use the calculator, and you can see it's almost like 99.4 or something, which is almost equal to 100. And that was our goal here to get this 100. See? Okay, so I hope that takes, and also 4.6. So this is this p that is 4.6, and you can also check what is ln of 100 from the thing from the calculator, and you'll see this is 4.6. On the calculator we can check, and let's see whether it is really true. So if we go and click on ln right here and put 100, see, and close it, and you get 4.6. And even if you try to take e this one and put 4.6, so this is the understanding of how logarithm is does undo log does undo or exponential does. So you can see here, if I can make it bigger. Oh yeah, look at this. So if it is 4.6, e raised to the input 4.6 is 99, which is almost like 48, and ln of 100 is 4.6. It gives back that number. So what does logarithm does is it does the in undo what the function e does. So input output is 4.6. So here this 4.6 gives you 99. That means ln of 99 is almost like 4.6. So that's what that. So what ln does is. So as we progress, we will see what's going on here. Okay, question number 2 it says retire a millionaire. Retire a millionaire. So it means when you want to retire, do you want to get millions of dollars? Let's take an example expression. The expression is 1 time e raised to 0.06 t models the balance in thousands of dollars of an account t years after the account was opened. So the question is, so in this case, what is, let's write down a function for this, even though they did not give us. So we can write this expression, like let's write it as a of t is the balance amount after t years is given by 1. Okay, and it's give you 1. This is already given to you 0, and you have to think of this side. What are those each of those uh, uh, numbers means. What is this one means? The first question is asking when the account is open, what was the balance when the account was opened? By just looking at this, you can compare this with exponential function with the base e. It is a times e raised to rt. It means when t is 0, when the input is 0, that means a. It means this is the graph, this is the graph, this is where the 0a is. In this example, you have the 1 here. A is 1. If you compare here, the A is 1. So answer for this is 1. So T is 1. So what that means is, sorry, not the T. So in the beginning, when T is 0, that means T is 0. So the A is in the beginning, it is 1. Now what does this mean? 1 is $1,000. It means it is $1,000. So that's what it means. So because it says thousands of dollars, so every number, let's see. So this one basically means it is $1,000. Let's see another question after 1 year. And you can also check this on the calculator. If I want to put A of, watch this fun. And on that same calculator, if you try to plug in, so this, you can see comparing R there. This R that you see here, see this part R? So that R is 0.06. That's the growth. This is the growth rate, and which is calculated continuously. So even though it is growth rate per unit increase, but calculated continuously with the, that's why that E is there. Okay, so this is 0.06, and then you multiply by 1, you see. So if I put 1 on the calculator, sorry, if we put a 0, the first, so you get on, because of this 0, this is going to be 1 times 0, which is going to be 1 times 1. Anything raised to 0 is 1, and the answer is 1. The second question is, we'll have to use the calculator, otherwise it's impossible here. So t is going to be 1 here, so there's a 1. So we'll put t equals 1, t is 1. So the function a of uh, now this one is in the beginning, that's the beginning one, multiplied by e raised to 0.06, and this time you're going to plug in, so you're going to plug in 1, you see. So this is like a 1. So when you put in the calculator, okay, now since you know already how to use the calculator, so the answer turns out to be here is you get 1.06184. So on the calculator, because of the time, I'm just not showing. So what this basically means, you want to know in dollars. So all you do is move 3 places. So when you go in the 3, it becomes 1061.84. That's the answer. So this is for the one. And the last one is when t is 2. So we'll have to put this, the 1 into e raised to, so same thing, everything, and put, so this 2 here, and when you put 2, you get, so I'm going to write here this answer, write it here, you get 1.1275. But then what this basically means is it is in dollars. You'll have to move the, okay, so that takes care. Then the question is, the next question is asking us is, Diego says that this ln phi represents in time, in years, when the account will have $1,000. Remember when I say $1,000 means, remember AT is, it was 1 e raised to 0.06t. So this piece, if it is $5,000 means I put 5 here. I want to see whether it's correct. Now this one doesn't, no need to write. You can just write like this, 0.6 times NT. Now we have to solve this for T. So how do I solve this for T is using logarithm. So the base right here is E. So this is the E. So when I use logarithm, this will go as the base. So this will become logarithm, okay, and the base will be the red one, which is E here, and the blue color, that this is the 5 that goes right here, and this part 0.06t, that will be like 0.06t. And then if you want to really figure out what is this t there, so you have to get away with this piece, so you divide by 0.06, okay. So this crosses, so you have to divide this side also 0.6. So the t equals, and the shortcut for log, so that when the base is e, we can just write ln of 5 divide by 0.0. So what Diego thinks that ln of 5 represents the time is wrong to have 5,000. So if you want to have a balance of $5,000, so if you calculate this, this is coming to almost like, let's plug it in and see what you get. ln of 5. So click on second ln. So yeah, just pick. So I want to have a quotient which is a division. Click on alpha y, so that way you get a fraction, and just enter 1. You can see the top one is 5. Sorry, ln of 5. So ln of 5, close it. And then the second one down, you put 0.06, 0.06. And you enter, you get answer. See, that's like 26, almost 26.8. Get back here. So this piece is 26.8, which is like 27 years. So after 27 years, the account balance will be 5,000. So I hope that makes. So then another question they're asking is, suppose, so there's the question, suppose you opened an account, this account at the beginning of this year, and assume that you deposit no additional and you don't take away any money, will the account be ever be 1 million? And make you a millionaire by the time you reach retirement. Let's imagine right now the student is 20 years old. So now today 2025 is 20 years, and then he wants to use 40 years. He works 40 years, and he wants to say how much is the amount, right? So let's take figure out what is this answer. So remember the formula A of 20. Sorry, A of 40, because he works 40 years. And we want to see how much money will be after 40 years. So that's like 40 equals, and 1 times e raised to 0.06 multiplied by, and you put 40 here and see, put in the calculator and see, do we get a million? And let's check it out. So if I put this and plug in 1 times, so it is 1 times e raised to open parenthesis 0.06 multiply by 40 years he works, close it, and you see what you get is. So if you work 40 years and you can see 11.0231, that means I have to move this decimal 3 places to the right. So it's going to be 11,023.17. So I'll go back here. So this answer is going to be 11. So it shows 11.02317. That means if I want to know exactly what is in dollars, it means it is, I have to move these 3 places, so it becomes 11,000 3.14. So that's 11,000. So you don't get $1 million. But question is it possible to get $1 million? So we have to fix maybe the rate of interest. What you see here is the rate of interest is 0.06, which is 6 over 100, which is 6%. The question is, can we change this to something different? So let me see what I'm talking about is here. So if you work 40 years with this interest, you make 11,000 after 40 years. Now, how many years will it take to make a million? So that means I have to make this as like 1 million. So for right now, I just want to cross this out. Don't want to get you confused with this. So if you want to get a million, the million is six zeros. That means we on the mathematical model, it's 1,000. So so the amount in the balance is like $1,000. So I put 1,000 here and then 1 times e raised to 0.06 times t. Okay, and then of course this one is not even needed. So I'll just take this off and write this in the logarithmic form. So when you write this in the logarithm, because there's a e, so we can just write ln of 1,000 and divide by. Of course, I think I made a mistake. So let's write a step here in the natural logarithm. This becomes equals uh, ln of 1,000, and this is 0.06 times t. And then you divide this by uh, 1,000 like this, and then you put this, and you end up getting on the calculator. You'll see. I think I have to check this. What is that answer? So here, if you plug in and get a fraction by alpha this, and then enter. So you put ln of 1,000, close it, and down you go and put 0.06. And if you enter, that's like 115 years. So what I'm saying, this will take 115 years. So that's like too long. You may not, you won't even exist. So is there a possible we can change this? So if you see this, are you ready for more? How is it possible to get 1 million if you put $1,000 in the now and you work for 40 years? So maybe you want to work more years. Let's see you are 20 and you want to work until maybe 65. That's like 45 years. So let's put it like this. So you want to work for 45 years. Any changes to get a million? What are the changes? You have to look out for investment where they give you good rate of interest, so percent increase. So you want to know which what percent increase is needed. So all you do is let's see, you don't know. Let's check what percent. So Noah. Oh, he said Noah is 15 years. Oh, this one is. Sorry, this is 15. I didn't realize that, and wants to retire as a millionaire when he's 60. So this is 60. So almost like 40, same thing, but he starts at 15. I'm sorry. So he starts at 15 and then he wants to work till 60. That's like 45 years. Yeah, same thing what I wrote here. So we want to know what is the rate of interest. So let's put one in the, this is 1,000. So that's 1,000 times equals 1 e raised to, we don't know, we want to know what is the rate of percent increase, and this is 45. See, and when you put this in the logarithmic form, so I want to write this exponential to ln form, so it becomes ln of 1,000 equals to 45 times r, and then you divide by 45, and this goes up when you get r equals this piece. So we'll put this on the calculator and see the ln of 1,000, close it, and divide by divide by 45. And you can get 0.1530. So let's try to go back here. So the answer you get is 0.1535. And if you multiply and divide by 100, because you want to change it to percentage, right? So this will be 15.35 divided by 100, which is 15.35. And there could be possibilities. There will be some where you can invest money, and there are places where they can give you this 35% per year. So hope this helps. So this completes 15.2. And the third task is about 15.3 cicada population. You can see the cicada population. And the question is the population of cicada is modeled by a function defined by FW is 250. You can see this. And W, what does W stands for? The number of weeks since the population was measured. So the three questions here. The first question explain why solving this gives the number of weeks it takes for the cicada population to double. So we need to know why, how does solving gives it by just looking at it. So by just looking at the equation, so this is the equation, and what you notice is this FW, which stands for number of uh, cicada population, is already given to you as 250. Or if you see this piece, if W is replaced by, let's say, 0, this whole thing f of 0 will be equals 250. So 250 times anything raised to e raised to 0.5. And if you multiply by 0, and you can see this whole thing will be 0. And anything raised to 0 is this piece, anything raised to 0, this will be 1. So what are you left with is f of 0 is 250. So explain why solving means in the beginning it was true. So this means this was when the study was being done, in the beginning, this is the population in the beginning, and then the output is given 500 here. So what it means is 250 population, which was 250. So in the beginning, when the population was 250, and then next one they say the population is 500 here. So the question is asking is W is the number of weeks and F of W is the population. So if you can see this, we want to know when is this going to be double. So this is like what is this? How many weeks does it take for it to be double? So double means it's like 100% increase, and 100% increase would be 1. That is 1 plus 1, that is like 2. So we want to know the factor, this multiplies 2, right? So let's see. Uh, Now the question is, we need to figure out when is this going to happen. So let's solve this. So let me write this equation. So 500 equals 250 times e raised to 0.5 and w. So the first thing we will divide by 250. So this is how we solve it. So 250 will be this 250 crosses out, and this will go twice. So it will be 2 e raised to 0.5 w, and then we use the definition of logarithm. Again, I always like to show that. So that means e raised to, let's see, if something x equals y, then this x equals, we put logarithm to the base e of y. But then we can write this instead of, whenever we use log with the base, you just write natural, because this is called natural base, which is E, Euler's number, which is 2.718. So especially on the calculator also, you will see it is ln, and that's how we write. So applying it right here, so the E's part is here, this is the input here, this is the input, and this is the output. So it just changes. That means when you use ln, so the input stays the same. That means 0.5 W will stay the same, and then you put ln of 2, and then divide by 0.5. So if you put 0.5 and you work this out on the calculator, you end up getting, so the answer this, of course, this will give you the exactly, uh, solving this will give you exact value, and that's going to be 1.4. Can always check this. So this will be after, that means this is 1.4 weeks for this to double. So let's go directly to the third question is asking us, is using the graphing technology, we can see, using graphing technology, how do we this and 100,000 on the same screen, explain why we can use the intersection points of the two graphs to estimate when the cicada population will reach 100,000. So we'll use directly the Desmos, which we have like this. So on the Desmos calculator, we'll put two equations, and the first equation we'll put is f of x w, or you can just write f of x equals 250 was the original, and then e to the power 0.5 x. So that's the first one. And the second one, you want to know the population when it's going to be 100,000 instead of 100,000. We'll try to use y is just put 100. So it means it is 100,000. So we'll use desmos.com, and then click on the graphing calculator. And here I will put the first one, which is f of x. Instead of t, I'm going to use x there, and the 250 was the beginning, 250, and then it is times e raised to the power 0.5, which is 50% times x. So this graph, and now the graph doesn't look good, so we'll try to do a little setup here because we want to see the whole graph. So we'll change the x-axis to maybe -1 to 16 here. And in this case, we'll change this to -1,000 to maybe, because they want us 100,000. So this I'll make it like 120,000. See? So now in the next one, we'll put the output. We want to know for how many weeks will it take for the cicada population to be 100,000. See, this is 100,000. You can see clearly, you can get this. And the answer is 11 point, almost like 12 weeks. So the answer would be, because the W coordinate of the point gives us the time in weeks. So in this W will give us the time in weeks when that happens, about 12 weeks. So that's it, we are done. So and the question is it possible to graph this on the nSpire calculator? Also you can do by just maybe okay, because of the time, I'm just skipping this. Let's go directly to the last question, and that is the cool down. So we'll go to cool down, and the cool down is okay here. So if you see the equation, this equation represents the area of a wall A in square feet that is covered by mold M months since the mold was first spotted. That means by just looking at it, this four, what does this four represent? So let me. So the cool down is, you are given the equation. This is given the area. This actually should have been area. I will just use, instead of this A, I'll use A of M. This represents the area covered by mold. So in the beginning, you can, by just looking at it, says 4 square feet was the, let's see if this is the wall, and the mold, which is the green color. So let me see if I can get a green color. So there is a green color, maybe this much is that area, which is 4 square feet. Now this area is going on increasing, And the way it is showing us, it is 0.45 there. And what is that 0.45 means? It is 45 divided by 100, which is 45%, almost like 50%. That means if I have this, that means uh, in one, since the input is the months, so in 1 month, this area, let's say this area, maybe become this much. So it's like 50%. So let me take this. This is the area. 50% increase means that's going to be half of this, or whatever this much maybe. And then again, whatever. So that's what it means. And then we want to know this whole area is given by 80 square. See? So so that's the understanding, the visual understanding of. So we want two questions. How do we use this graph that is shown to figure out when is the entire wall will be covered in mold? And you can see the 80, just look at this 80 right here. So this is the 80, so that's the one. So you go, so you draw a line. Of course, on the Desmos also you can draw the line y equals 80, and you'll see it hits the graph at exactly somewhere here. And then you can go down all the way to check the input for where does it cut. And you can see almost like 6.6, maybe 6.5 also, we don't know. But when you put it in the calculator, you can get the answer. Now, that's the first question is use the graph representing this to estimate. So we estimated this or this, both answers are correct. But the second question is, can we use the equation? So the second question is, so the equation is given e raised to 0.45 m. So this is the equation that we have to solve when the output. So when is this whole wall is going to be? This wall is going to be filled entirely with the with this with the mold. So that's the green color mold, right? So we need to put the output. That means A of t. This is the area after that many weeks, or m, maybe m. Okay, sorry. Yeah, months. I already used this. So this is m. So when is this going to be? When this is 80, so what is the answer? How do we do this? Okay, let's put it. So the equation is A of m equals to, yeah, so the equation here is actually, I forgot that's 80, right? So this is 4 here, sorry. So in the beginning it was 4. So we'll write 4 times and then e raised to 0.45 and m. Then divide by 4 the whole thing, and quarter of 80 is 20 equal, this will cross out and you get e raised to 0.45. And let's change this to in the from exponential form to logarithmic form. So when I use it is a logarithm or base, this is the base which goes right here of, this is the output, this is the input. So we just have to interchange input and the output. So that becomes log of 20, which is equal to 0.45 and m. And then this whole thing is shortcut is ln of 20, which is 0.45 m, and then divide by 0.5. If you put on the calculator, so you end up getting 6.6. And that's it, 6.6 months it takes for the whole thing to get. So which was almost like we estimated this to be, remember we estimated this is 6.6. There you go. We are done. So this takes care of the whole lesson. So just finished lesson number 15, and this was lesson number 15, solving using graphs. So what was the thing? We were using the graph. So we are two things happening. One is the graph, and the other one is the logarithms. So how are these two things we are using to solve problem? That means sometimes we just use uh, graphs. That means first is the exponential graph will go like this, and then sometimes they give you the output and just have to draw the blue line like this, and you'll see they cross each other. So this is like maybe output y something, I don't know, I'll just put p, and this red color is the equation maybe y equals a times e raised to rt. The point of interest will help us to figure out what is this t, the variable t, uh, so that the output is, which is already given. So this is given to you, and you have to figure out what is the input t here. This is one way to do, and another way to do is by directly going on the calculator and you just put those two equations on the dash. So you can do this in the desmos.com, or you can also use TI 85 plus, or you can also do it by Nspire KCAS, and you can get the same thing. So see you then. The next video that I'm gonna make is lesson number 16. Thanks for watching.